centimeters of tap water. Rusting Q1, steps, get an iron nail with 2G mass. Get a test tube and add 10 cubic centimeters of tap water. Place the iron nail in the test tube and leave it to rust. Observe the nail after a week. Repeat the experiment using the other 2 water samples using same volume of water and same surface area of nails, and leave for same time. Compare the mass of the rusted nails, and the largest change in mass will have rusted the fastest Q2. Steps. Get a steel nail with 2G mass. Add 10 cubic centimeters of water and 5 cubic centimeters of corrosion inhibitor, R, to a test tube. Place the nail in the test tube and leave it for a week to rust. Repeat this process with the inhibitors Q and S using same volumes and duration, 1 week, and same mass and surface area of the nail. Compare the results. The nail with the least change in mass will have the strongest corrosion inhibitor. 5. Preparation of salts. Q1. Add dilute sulfuric acid to a beaker. Add excess magnesium oxide to the beaker. Heat the beaker on a Bunsen burner. Filter the excess unreacted magnesium oxide. Heat the solution. Filtrate till crystallization point. Check for crystallization point by using a glass rod. Leave solution to cool. Filter crystals, dry crystals gently using filter paper. 6. Extraction of metals. Q1. Steps. Crush malachite using mortar and pestle. Add nitric acid to the malachite solution is formed. Add zinc metal or magnesium metal, any metal more reactive than copper. Displacement reaction occur. Filter wash residue and dry between 2 filter paper. 1. Comparison between production of energy Q1. 1. Steps. Add the first fuel, diesel, to spirit burner. Measure the initial temperature of water. Start burn for certain time. Stop the reaction, then measure the final temperature of water. Repeat experiment using the second fuel, biodiesel. For fair comparison, use same volume of fuel, same volume of water, same time interval, same distance between tube and burner, same initial temperature fuel, with greater temperature difference produce more energy. Ideas for paper 6. Last question. Q2. Steps. Hold the test tube of water with stand. Put the peanuts below it. Measure the initial temperature of water. Start burning for certain time. Stop the reaction. Then measure the final temperature of water. Repeat the experiment with the other nuts, Brazil hazelnuts. For fair comparison, use same mass of nuts. Same volume of water / same distance between test tube and the nuts / same initial temperature. Nuts with greater difference in temperature produce more energy. Q3. Steps. Use equal mass of coal. Crush it with mortar pestle. Put the coal in fume cupboard and start heating. Pass it through potassium manganate. 7. Then measure time taken for purple to become colorless. Repeat experiment with the second type of coal using same mass and same surface area. Coal with less time taken for color to disappear produce most sulfur dioxide. 2-dot separation methods. Q1C1. Steps. Crush the leaves with mortar and pestle. Draw baseline with pencil and chromatography paper. Using glass rod. Add drop of sample on baseline. Place the chromatography paper on solvent, ethanol, level below baseline. Leave it for certain time. Color spots start to appear on chromatography paper. Q2. Steps. By simple distillation, boils the mixture. Then condense the vapor, collect the liquid. Steps by filtration. Sand in residue. Wash the residue dry between 2 filter papers. 4. How to determine. Q1. The concentratin. Steps. Add 25 cubic centimeters of clean up-in flask. Add nitric acid to the burette. Add indicator to conical flask. Start adding acid to the flask until indicator change color to neutral record volume of acid used, then calculate the concentration. Know of moles of ammonia. Know of moles of nitric acid, CXVCX. VQ2, the percentage steps. Weight, the mixture 100 g. Add excess sulfuric acid, warm and stir. Filter, wash and dry the residue, carbon, between filter paper. Then the mass of residue. Calculate the percentage 100 carbon mass. Q3, the maximum mass. Steps. Use mortar and pestle to crush calcium granules to increase surface area. Add the powdered calcium to crucible covered with the lid to prevent loss of calcium oxide. Smoke. Start heating. Calcium oxide is produced. Stop the reaction and use balance to measure calcium oxide. Mass. Then reheat till constant mass and remeasure to make sure all calcium converted to calcium. Oxide. Finally, subtract 2G from calcium oxide. Final mass result, and the rest will be the mass of oxygen. Q4. The solubility steps. Measure 100 cubic centimeters of water using measuring cylinder. Heat to 40 OC, add potassium chloride until no more dissolves. Stir filter, the mixture evaporate. Filtrate to dryness. Weigh the solid using balance. 7. How to prepare an indicator. Q1. Steps, crush the berries with pestle and mortar. Add water and mix. Then filter off the filtrate is the solution of an indicator. Q2. Steps, add the indicator to hydrochloric acid. Add the indicator to sodium hydroxide. Colors must be different for each solution. 11. Differentiate between two solutions. Q1. Type of the solution steps. Add xmr3 of solution H to boiling tube. Add manganese 4. Oxide. Connect gas syringe to collect the gas. Start heating for certain time. Measure total volume of gas produced. Repeat the experiment with solution J, using same volume of hydrogen peroxide and same mass of manganese 4 oxide. Finally, the solution that produces large volume of oxygen gas is the new one. Q2. Strength of the solution. Steps, add 25 cubic centimeters of hydrochloric acid to a clean conical flask. Add few drops of methyl orange indicator into the conical flask. Fill the burette with oven cleaner. See and note the starting volume. Start titration until the color change. Then stop adding oven cleaner. See and note the volume added. Repeat the experiment using same volume of oven cleaner B and same volume and concentration of HCl. The oven cleaner that use less volume to neutralize acid is the more concentrated 1,8 reactivity series. Q1. Steps. Use 10 cubic centimeters of hydrochloric acid in test tube. Add zinc metal. Count the number of the bubbles. Repeat experiment with silver and tin using same mass and surface area of metals. The metal with the highest bubbles is the most reactive. 2-dot catalyst. Q1. Steps. Use same volume and concentration of hydrogen peroxide. Add copper oxide to hydrogen peroxide. Measure the volume of gas produced per unit time using a gas syringe. Then compare that to the volume of gas produced from hydrogen peroxide without adding copper oxide. Compare volume of gas produced Q2. Steps. Weigh the copper oxide before adding to the hydrogen peroxide. After the reaction is done, filter the copper oxide from the solution. Dry it using an oven or between two filter papers. Weigh its mass. Compare the final mass with the initial mass. 10. Electroplating. Q1. Steps. Prepare a copper sulfate solution. Set up a circuit and a source of electricity. Clean the ring using sandpaper. Place the ring at the cathode. Place the copper rod in the anode. Switch on electricity. Make sure the ring is being rotated. Remove the ring after electroplating and wash it.